The Lewis electron dot diagram for C2H4 is shown below in the box on the left. In the box on the right, complete the Lewis electron dot diagram for C2H5OH, or ethanol, by drawing in all of the electron pairs. So as I said, this right over here, this is the Lewis electron dot diagram for ethene, and they want us to fill in all of the, they want us to draw in all the electron pairs for ethanol. And what we could do, and I'll do it in a way where we can see which electron comes from which atom, but they're not even asking you to do that. But in blue, I'm going to make the electrons from the hydrogens. So each hydrogen, you can think of it as contributing one electron to each pair, and that's what's forming the covalent bonds. So say this hydrogen is going to contribute this electron. This hydrogen can contribute this electron. This hydrogen can contribute this electron. This hydrogen can contribute that electron. This hydrogen can contribute that electron. This hydrogen can contribute this electron right over there. And then let's see. So now let's think about the carbons. And if you were actually taking the AP test, you probably don't even have markers around, but I'm going to do it in different colors just so you can see it. So each carbon has 4 valence electrons that it can contribute for covalent bonding. So this carbon right over here, that's 1, 2, 3, and then 4. And now this carbon over here can contribute 1, 2, 3, and 4. And now we think about the oxygen. So oxygen is interesting. It's going to have 2 lone pairs. So it's going to have 1 lone pair. I could do it there, 1 lone pair like that. And then it's going to form this bond by contributing 1 electron to this pair and 1 electron to this pair right over there. So each of these pairs represent a covalent bond. This one I could have drawn a little bit lower, but I think you get the idea. Those I have drawn in all of the electron pairs. Now let's think about part E. What is the approximate value of the carbon-oxygen-hydrogen bond angle in the ethanol molecule? So in the ethanol, they're really saying, so the ethanol molecule, they want to know the bond angle. You have the oxygen bonded to a hydrogen bonded to the C2H5. So I'll just write that as I'll just write C2H5 like that. And they want to know what is approximately this bond angle going to be. And the important thing to realize is when you form these bonds with oxygen, it's going to have pretty close to a tetrahedral shape. Why? Because the oxygen has these 2 lone pairs. So these 2 lone pairs are forming the other parts, the other, I guess you could say, points of the tetrahedral shape. And so if we were talking about just water, so water, if we're talking about a water molecule right over here, and I'm not doing a good job of drawing it, you could draw 1 electron pair there, and then the other electron pair would be here in the back. Actually, let me draw it like this. I could draw it like this. If we were talking about water, I could draw 1 hydrogen popping out. I could draw the other hydrogen popping in, and then 1 electron pair is over here, and 1 electron pair is over here. This bond angle over here in water, and this is, I guess, a semi-useful thing to know in general. You could try to eyeball and say, oh, that looks a little bit more than 100 degrees, and you'd be right. This is approximately 100.4.5 degrees. And this is actually not a perfect tetrahedral shape. It gets distorted because these lone pairs of electrons are repelling each other and making these 2 get in a little bit closer together with each other. If you have a pure tetrahedral shape, so you have something in the middle, well, if you had a pure tetrahedral shape like this, so let me draw it like this. So something popping out, you have something going in, and then you have 2 things like this. That's one way to think about a tetrahedron. There's others. Then the bond angle between all of these, if it's a more, I guess you could say, symmetric a non-distorted tetrahedral shape, is 109.5 degrees. And this is a reasonably useful number to know, obviously, for this question as well. I don't know if you can, if this is obvious. Let me actually draw the tetrahedron. Let me connect the tetrahedron. So you could draw it like that, and then that would be the other side right there. I don't know if that helps. Let me draw another one. So if I were to draw a tetrahedron, and if this was transparent, you have a molecule, or you have an atom in the middle, and then you have the 4 bonds. 1, 2, 3, 4. I could say 4 bonds or lone pairs. Then, let me make sure you can see the one in the center. Then the angle here is approximately 109.5 degrees. So this is going to be tetrahedral, but you have these lone pairs that are going to be repelling each other a little bit. So you're going to be someplace in the neighborhood of, I don't know, around where water is, or a more pure tetrahedral shape. So I would say your bond angle is going to be, I don't know, between 104 and 110 degrees. 104 to 110 degrees. In fact, I would estimate that it's going to be more than 104.5, because these well, I won't try to dig too much into it. They really just want us to approximate the value. So you could give anything in this range would be a suitable answer.